So these are just the multiple choice type of questions here. John did not study for his test and wants to answer 3 multiple choice questions. Each question has 4 possible answers, so A, B, C, D. This only applies to scenarios where every question kind of looks the same to you. Everything is kind of like equally spread out. You're not really thinking, right? You're just randomly choosing, okay? So how many outcomes are there? So we're just interested in outcomes. I will just use the fundamental counting principle for this. So that will be, you have 3 questions, and we've got 4 choices for every single question. Okay, so that's 4 to the power of 3, and that is 64 outcomes. If you looked at my key, it probably has like a makeshift tree diagram. I wouldn't expect you to make a tree diagram where there's 64 branches, but that's what it would look like. 64 outcomes. Can you do a table with this? Can you do an outcome table in this scenario? No, because you have 3 events, right? Question 1, question 2, question 3. So there are 3 different events. So if you only had 2 questions, you could have 4 options at the top and 4 here, right? Then you could come up with 16. That I would expect you to do. How would the outcome change if we eliminated 2 options for each question? Right? You know the very obvious ones, right? Like, let's get rid of some. So then basically, the 3 questions, you narrow it down to 2 questions, 2 questions, 2 questions, right? You only have 2 options because you've eliminated 2. So this would be 2 to the power of 3, which is 8 outcomes. So you significantly increase your chances of getting something right if you remove the obvious ones that are not supposed to be considered, okay? Next, Trent did not study for his test, and he wants to answer 6 multiple choice questions. Each question has 5 possible answers. Determine the total number of ways that he can answer this. So 6 multiple choice questions. These are 6 events. So question 1, 2, 3, 4, 5, 6. A common mistake is that students say, oh, 5, because I see the 5, and it's going to be 6 in each slot. That is wrong, right? You got to make sure you understand this is question 1, question 2, question 3. If you need this for your notes, why did we come up with 6 slots? Because there's 6 questions that I need to answer, and each one of them has 5 options for you. So this is 5 to the power of 6, right? So this is a bit of a pattern. This would be events, and this, the base is your options per event, okay? That is probably a good note to have there. And what is that, by the way? You're going to get really big numbers from as we go along. So we're learning how to count something that would be very, very time consuming to do it like one by one, right? So we're learning how to count really big numbers. So there's this many outcomes, how many different ways you can answer that test, right? So just think about it, right? You go A for the first one and then B for the next one. And then you go maybe B for the first one, A for the second one, and then it just all these different permutations you're considering here. So 15,625 unique ways. By the way, how many of these gets you 100% on the test? How many of these 15,625 ways to answer gets you 100% on the test? Just one way. There's only one that gets all of them right, okay? But this is how many ways there are to answer. But there's only one way to answer every single question correctly, okay? That's coming down the pipe, so don't worry about it too much. Example 7, if there are 5 racers competing, how many ways can the first, the second, and the third place be arranged? Since we are talking people, there cannot be repeats, right? Like you're, so you've got first, second, and third place. Okay, and so you start with 5 racers. So out of the 5, you choose one person, but you've got 5 options. Okay, so remember that I think some of you found it useful to say -1, right? Like we're taking 1 out of the 5 to be the first place. And then there's 4 left, it's -1, right? And then 3 left, so and so forth, right? So this will be 20 times 3, which is 60 ways. I'll say this, you're gonna have to read carefully, okay? So I'll give you a different scenario. I won't add it to the notes right now. But let's say you're getting an award. It's the end of the year and it's time to give awards out to students. Can a student get more than 1 award? Yeah. So in that case, you could be like, how many students would get this first award? It'd be 5, right? How many get the second award? You still have 5. For the third award, you still have 5. So in that case, we wouldn't take away. But if, let's say the school says, hey, you know what, that's not fair that one person gets all 3. We'll just do 1 award per person, max. Then you'd go 5, 4, 3. So you have to be reading carefully. What does the question suggest? Okay, next. How many different words can you make with the letter, with the word in the letters in the word boring? Okay. So the key here is to count 1, 2, 3, 4, 5, 6. 6 options. Okay. So the key here is you still have 6 slots to fill. You've got this bag of letters. Let's imagine you print boring nice and big, and then you cut up the letters, and you've got 6 options, right, to fill in and make another word. Some of them won't make sense, right, but we still consider it a word. It might be like a toddler babbling or whatever, but it's still a word. So we start with 6, right? You've taken it out of that pot of 6. So you're down to 5, and then you're down to 4, 3, 2, 1. Not 0, because then the whole thing is 0. So this would be 6, 5, 4, 3, 2, 1. If you multiply all of that, you get 720 words that you can make. And I do want to make, it implies that you cannot repeat letters, okay? You can't use B multiple times. Like if you take B for the first slot, that's it, right? You're down to 5 for the next slot, and you're down to 4. So this type of question implies that you cannot repeat. Okay. If the question says you have infinite number, like you can use B multiple times, repeats are fine. They would have to give you that extra bit of information. Okay. All right, let's go to 7. Oh, this is the one, I think. Yeah, this is the one where it's bursary. Same idea as an award. There are 30 people that applied for bursaries this year. There are 5 bursaries to be selected for. Determine the number of ways that students can be selected to receive these bursaries. Like it's kind of like the same, it's a monetary amount, right? You get some money. Okay. If participants can receive more than 1 bursary, okay, so I will write down repeats are okay. It's basically telling you repetition is okay. Like when you make your password, right, you can use more than 1. So we've got 5 bursaries. Bursary 1, bursary 2, and so forth. And because we can have more than, like the same student receiving multiple, you just write it like that. Okay. So that would be 30 to the power of 5. Okay. And that would give you a big number, 24,300,000. And I really wish our calculator would have commas. It doesn't have commas because once you get to really big numbers, it gets kind of tricky. All right, if participants can only receive one bursary, it's basically saying no repeats. Okay, the same as saying no repeats there. So 1, 2, 3, 4, 5. So you start with all 30 being available for the first bursary. One has been selected down to 29, 28, 27, 26. And so that is, if you multiply that out, is 17,100,720 ways that you can spread the bursaries. And obviously you would assume that all of them are equally qualified, right? But right now that's not a probability of one student getting it over the other. It's just how many ways would there be, okay? License plates, I'll do that because I haven't done. So there's postal codes, license plates, all of those are kind of like one category, very classic. And then there's passwords. Passwords are very classic. The like the word being cut up and making new words, that's a classic. So all of these are very classic. After a while, you'll be like, oh yeah, I know where this is going. I know where this is going. That is if you do your homework, I would say. If you just do what's in class, you're gonna probably be drawing a blank sometimes. So license plates for vehicles, you have 3 letters followed by 3 numbers. So it's how many possible combinations are there if repetition is allowed? So you've got letter, 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 number, number, number. So that's the format we're following. I want to mention something here, okay? Please know that there's 26 letters. Some students come up with weird numbers there. So 26 letters. And 0 to 9 is 10 numbers. Digits and numbers, same thing. So, okay. If it says characters, it could be letters and numbers mixed. Make sure you have this somewhere on your study sheet. Characters means you can use anything you want. You can use letters, you can use numbers. Oh, I should say this, special characters, my bad. Letters, numbers, and special characters. What would those be, special characters? I would have to tell you. So let's say exclamation mark, question mark, hashtag, and so forth, right? Those are special characters. So when it says characters, it just means I don't care, just use whatever we make available to you. Okay. Oh, one more. Uppercase would be 26, right? Lowercase, you also have 26. So if a password says you can only use uppercase, of course you've got 26. If it says a password can have uppercase and lowercase, you can use both. How many do you have in total? 52. Okay. It's getting crowded here. I might have to redo this later. You know how we refer to 52 if we care, if it's lower or uppercase? I'm going to zoom into that part so you can see it better. It's called case sensitive. I'll probably redo this at some point later on. Maybe remind me of that later on, but these are just some things in the background when it comes to passwords. This is password specific. Know that there's 26 letters, unless they say don't use I and O. Sometimes they say we do not use certain ones. You got to subtract that, of course. If it says digits, you're assuming 0 to 9. Sometimes they say you cannot use 0. Okay, you got to get rid of that. You're down to 9. Characters, any characters, they will have to specify. Can you use only letters? Can you use only numbers? Can you use both? Are there any special characters? Is it case sensitive? If a password is case sensitive, you immediately assume that 52 letters are available because lowercase l and capital L are two different entries for the password. Okay? So make sure you have that on your study sheet. You will come across that, guaranteed. Like there's not even a question that you will come across these things. Okay? So if this says you can use letters and it's case sensitive, for sure you know you have 52 options per slot. Okay? If it says you can also use numbers, what's 10 and 52, right? We're down, now we have 62 options for every slot. If they don't care where we put what. Okay? So that is just an aside, a big aside. So let's go back to this question on license plates. We can only use letters here. And if you've looked at a license plate, it's capitals only, right? So we have 26, 26, 26, and I've got 10, 10, 10. And I just used up my whole space there to actually answer this thing. But it really boils down to 26 to the power of 3 times 10 to the power of 3. And if you crunch those numbers, I'm on the wrong page here. That's 17,576,000 plates. Yeah, like so Manitoba, I'm sure you're aware that not postal code, our area code changed, right? It's 431. 204, we ran out of numbers. So they had to like add 431 because now these people have like 10 cell phones in the home or whatever, like 5 numbers per household. It used to be like one home phone, that's it, right? And now all these cell phones got added, so they had to add more numbers. So that's why we have 431 to make more combos, right? That's basically what they did. How many combinations are there if no repetition is allowed? So no repetition. So when it comes to the letters, it's 26, 25, 24. When it comes to the numbers, it's 10, 9, 8. If you multiply that all out, you get 11,232,000 plates. And of course, the more restrictions you put on, the fewer plates you're going to have available. Okay? I'm going to add a very important question at the bottom of this page using these two answers. I want you to start thinking about that. MPI allows customers to buy Winnipeg Jets plates that start with a J and then have 1, 2, 3, 4, 5 slots, or WJ with 4 slots. Okay? I was assuming you all knew the special plates. I should have specified. So there's only numbers that follow the first 2 letters. Okay? That's all you have. So the option 1, you've got a J at the front, okay? That's 1. There's only 1 slot that can be filled there. And then you've got 5 that have numbers only. Okay, multiply them all. That's 10 to the 5. That's 1 followed by 5 zeros. Then you've got option 2. You've got W and J. It's just one option there. This is kind of irrelevant, like you don't have to do that, but then you only have 4 slots available, and those are all numbers. Okay, so this would be 10 to the power of 4, which would be 1 followed by 4 zeros. And apparently I made a mistake on my key. Apparently I don't know how to do powers. I'm missing a 0 on each one, so my bad. I'm going to have to fix that. I see that actually, yeah. So this would be 110,000. plates that can be made. So you need to add when it's the or. And I do make them capital for now, but down the road, you're going to have to see like what's happening here. It's the or. Okay, so the or tells you to add the two different branches that you went down. Okay. D. I'm going to add one here, and I'm going to use A and B for this. How many plates have at least one repeated character? If I asked you that, I want you to start thinking, oh, it's the at least thing. At least one repeated character. And I'm going to zoom out on this one because I want you to see A and B. You sort of see it, right? And so what I want you to think is indirect reasoning, where we say, we're going to say total. What happened there? Sorry, I'm too excited for the weekend, guys. Total minus outliers. Sorry, I'm not going to use outliers here. My bad. That's how excited I am for the weekend. I'm going to go total plates, like all possible plates, minus plates without repetition. I'm going to go total plates minus plates without repeats. And so I'm going to use 17,576,000 plates, 17,576,000 minus, I'm going to take away the plates that do not allow any repetition. I already figured it out earlier. So I'm going to go minus 11,232,000. And I need to do the math here because I didn't plan on doing this. $6,344,000 plates will have one or more repetitions. Okay, let me zoom into that and bring it further up for those that are in the back there. Okay, so these are all possible plates if there's no restriction. Repetition, no repetition. It has all the plates. Take away the ones that we calculated have no repeats. That's how you figure it out. Figuring this number out otherwise is very, very difficult. You have to use indirect reasoning because you can't think of all possible plates that have one or more repetition. It's very, very difficult to do, especially when it comes to the millions, right? So that's how you do that. You do it indirectly using. Basically, this is how we figure out. This is kind of universal minus outliers. That's the scenario here that we're using. Okay, before you get the AC, I'm going to do the roads real quick. I want to make sure you know how to do roads. It's a very classic type of question. So I'm going to actually, at the top of this page is number of roads or something that sticks out. And I'm just going to say, read carefully. I can't cover all possible scenarios, but if you know the basics, you'll be fine. So it says that there are 5 roads from Winnipeg to Banff and 4 roads from Banff to Castlegar. And you will also notice that sometimes it's conveniently A, B, and C, like Alberta to Banff, that's A and B, and then Banff to Castlegar, that's B to C. Not always, but quite often. If you cannot travel the same road twice, how many ways can someone travel from Winnipeg, right, from Winnipeg all the way to Castlegar? So we'll start like this. I go Winnipeg, Banff, and there are 5 roads. So you just make 5 roads, 5 lines. There are 5 options to get from W to B. And then there are, how many? 4 roads to go from Banff to Castlegar. So you go 1, 2, 3, 4. Okay, so this is the illustration. So there are 5 options to go from here to there. There are 4 options to go from B to C. So if you don't want to sketch it, I would say at the very least you say that from W to B there are 5 options. So that's like the slot. The first event is going from here to here. There are 5 options times the second event is going from Banff to Castlegar. There are 4 options there, so there'd be 20 ways to get there. 20 ways to go from Winnipeg all the way to Castlegar. Okay. We just did this. Sorry, guys. This whole thing illustrates that. Technically, the math I did here, but it is 5 times 4, which is 20 ways. Not too bad. You don't have to worry about the not taking the same road more than once in this case. But what about if it says a round trip? A round trip. So you're going from Winnipeg to Castlegar, and then you're going back to Winnipeg. How would we do that? So you go Winnipeg to Banff. There's 5 options. From Banff to Castlegar, there's 4 options. So that gets you from Winnipeg all the way to Castlegar. But now you need to come back. So watch this. We're going from Castlegar to Banff. Right, we're here. We made it here. Now we're going back. How many roads can you take if you're not allowed to use the same road again? How many options do you now have going back? 3. Yes. And what about from Banff to Winnipeg? You've taken 1 of the 5s already on your way there. So how many are left when you come back? 4. Okay. So I will make a note under here. So you go 4 minus 1. That's how you get the 3. And then you have 5 minus 1. That's how you get the 4. Okay? And so it's 20 times 12 essentially. So now, like, there are 240 ways that you're going to consider for a road trip, right? Like a round trip, like there and back. Okay? And the picture. This is a classic as well. All of these are classics, and you're getting sick of classics, right? There's 10 people that are lining up to take a picture. Those 10 consist of 8 players and 2 coaches. Okay? How many ways can the team just line up for a picture? And so basically, there are 10 slots that you need to fill. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you have no restrictions, you're just going to go like this. I know it's very tedious. We're going to have a shortcut for that coming up. But there are really 3,628,800 ways to get that done, to arrange. And so, right, if you move one person over, you just flip one, that's one different, there's a different picture. If you have, right, like, so there's 3,628,000 and some ways of different ways of taking a picture. That's true, okay? How many ways can the team line up with a coach? There's a typo there. Line up if a coach must stand on either side of the setup. So now there's a restriction here, folks. It's gonna be less than what we started with. Okay, so let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You need a coach here. You need a coach there. That's a must. And then the 8 players fill in the rest, right? So how many coaches could you put in this first position here at the very beginning? 2. And so how many are left to put in the back then if you've used one already? 1. Right, so there's 2 ways. There's essentially 2 ways. You could have Coach Albert and Coach Johnny on this side, and then you can flip them, right? Just 2 different ways of moving the coaches, right? What about in the middle now? You have 8 players, right? You can have 8 to fill this slot, 7, 6, 5, 4, 3, 2, 1 to do the rest. So these are the players. They can be moved any which way, but your coaches have to be on either end. So they cannot be part of that middle 8. Okay? So that's how that works. So if you want to do this, I'm going to just get to the finish line on this one. It's 80,640 ways. And I know what I'm going to do now is work. It's more work than what I just did. But maybe some of you are going to appreciate this method more. So let's assume you've got coach. Let's just make 10 of these. So 5. I would encourage you to do that no matter what. Just do it. 5 and another 5. So let's say you start with coach 1 here and coach 2 there. So they each have a name, right? They're different. Okay, so then you only have 1 here and 1 there. And the rest, you fill in with 8 times 7 times 6 times and so forth. But you could also say, or, I'll make 10 lines here, do this again, 10 of them. Or you put this coach number 2 that used to be on the right side, you put coach 2 up front, so that's one option there, and you take coach number 1 and put coach number 1 on the right side, just one slot, and you've got 8, 7, 6, 5, 4, 3, 2, 1 to fill in the middle. What are we going to do with these 2 answers that we're going to get here? The or gives it away, right? So you consider the first case, which is 40,320, and you get the exact same answer again for the second. Guess what this is going to add up to? 80,640. So you decide how you want to tackle things. Whatever makes sense to you, do it. Like break it down, do cases, just make sure you add it up when you're done. Okay? So either way of doing it, and sometimes students do both just to make sure they get it right. Because if these numbers jive, then you're probably doing it right. Okay. So we've done roads, we've done lining up for pictures. That one is I will just have like a little subheading here, somewhere on the side here, pictures. And this is going to get complicated, okay? It's like, oh, Martha and Ariana want to be together on the picture, no matter what. But you can move them anywhere you want, but those 2 need to stay together because they're best friends, right? So it's going to add a bit of a layer, not now, later. But that's happening too down the road. Or there's a group of 5 friends in this group of 8 players, We want to be together no matter what. How do we keep those 5 together as we move things around? We're going to talk about that as well. But pictures for now. So roads, pictures, license plate, passwords. Very classic, okay? Classic, classic. So if you're right now overwhelmed, if you do the work that I'm assigning, you can go back to these pages and hopefully they help you out and they tell you kind of what to do in these scenarios, okay? For example, I know you're tired of listening to me. What if there was a third coach, an assistant coach yet, or like the equipment manager? Like 3, but right? Like how would you do that? Maybe that third coach would have to be in the middle somewhere. We'll figure that out as we go, okay? But it would be 3, 2, 1. Like you would first do the coaches, put them where they belong, and then fill the rest with the players. Okay, that's kind of how we would deal with it.